Hello, I'm going to do a really quick review. You're going to notice I've got a lot of things done ahead of time because I want to make sure I can squeeze in a lot here. First of all, you should know for a right triangle, the two things next to the right angle are called legs, and the side opposite from the right angle is called the hypotenuse. And we use the Pythagorean theorem, a squared plus b squared equals c squared, to say, hey, whatever this measure is squared plus whatever this measure is squared will equal this measure squared. Which means usually I've got two of those, and at the end I've got to take a square root to figure out what the missing side is. You should know what a square looks like. You should know if you cut a square in half. This line here, which I could call a hypotenuse, I'm probably going to call a diagonal. It makes what's called a 45-45-90 triangle, or half a square. And occasionally you might even call this an isosceles right triangle because this side and this side are congruent. I got an example here, and therefore it is isosceles. It also happens to be a right triangle. So these three terms are synonyms for one another. If you're giving a descriptive question, you've got to know what those mean. Otherwise, you have no idea what kind of triangle I'm talking about. Finally, you should know what an equilateral triangle is. Equilateral triangle, from its term, means all sides equal. But then because all the sides are equal, the angles opposite from all those sides are equal, which means they all have to be 60. If I chop this in half by putting in what's called an altitude or a height, that's simply something that connects from one vertex perpendicularly at a 90-degree angle to the opposite side. It will essentially create symmetry there, where you could fold that in half and you create what's called a 30, 60, 90 triangle. And that's normally just what that's called. It's not normally called half an equilateral triangle. It might be called an equilateral triangle with a altitude in it. And then the other thing you should just recognize, in the same way that this thing all has 60s because the sides are all equal, the 30 side is opposite from the shortest side, and the 30 angle is opposite from the shortest leg. And the 60 angle is opposite from the longest leg, and then obviously the 90-degree angle is opposite from the hypotenuse, which is the ultimately longest side. Okay, that review took a little bit longer than I wanted. Go back and watch it again if you need to. The other thing you need to know is equivalent answers. When I'm doing an a squared plus b squared equals c squared, very often I will end up a square root at the end. So I've plugged this in, I've gotten square root of 20. Square root of 20 is the answer. Okay, that is the exact answer. If you put it in your calculator, it's about 4.5. It's a little bit more than the square root of 16, about 4.5. But your calculator oftentimes, depending on what you have, will give you 2 root 5. And the question is, well, why does that happen? And so I just want to show you really quick why that happens. The square root of 20 is the same as the square root of 4 times 5. Okay. Now, I can break this apart. It's perfectly legal for me to say this. That's the same term. If I put that in my calculator, square root of 4 times the square root of 5, it still gives me the 4.5. But the square root of 4, we know what that is. It's 2, and that's root 5. And so this means 2 times root 5. Root 5 is about 2.2. It's a little bit more, which is why this rounds to 4.5. But that is an equivalent form. You just need to recognize, especially like for a multiple choice test, you might get this answer instead of one of these two answers, and you have to know, oh, that's the same thing. It's just been put in better form. All right, moving on to the task at hand. When we've got half squares, we can do Pythagorean formula on them, and what we find is, oh, that's square root of 2, or about 1.4 is what that is. This one right here, square root of 18. So if I do that thing in my calculator, that's square root of 9 times square root of 2. It's 9 square root of 2, or 9 times 1.4 is whatever that is. I can't do it in my head real quick. And then this is 10 squared, once again, square root of 200. Oh, same thing. Square root of 100 times 2 is going to be 10 is the square root of 100, and then I'm left over with square root of 2. Square root of 2 is 1.4, so this is about 14. And once again, 10 and 14, that seems reasonable numbers. 1 and 1.4. What I should not get here is 20 or something less than 10. Those would not be reasonable answers. So let's try one of these real quick. So if that's 4, that's also got to be 4. These are half squares, or 45, 90 triangles. And then I can go through this business again, but what I should notice is, oh, wait a second. I am always multiplying by the square root of 2, or 1.4. So no, it's a little hard to read. Okay, so this answer is just 4 square root of 2. I don't have to do any work there as long as I remember that relationship, that whatever this is times square root of 2 or times 1.4 will give me the hypotenuse. So where that becomes really important is a problem like this. If I'm working backwards, there is no easy way for me to figure these out other than guess and check, which I don't want to do, other than knowing this relationship. So if I'm multiplying by square root of 2 to get longer to go hypotenuse, what do I need to do to go in the other direction? That's right, I need to divide. So I'm going to divide by the square root of 2. So this right here will be 12 over the square root of 2. And this also, I'm going to change colors. This will also be, I'm going to do it down here, 12 over the square root of 2, so you can see it really well. Now this is correct, but it's not in the best form, and I've gone over this before. The way to fix this, other than put it in your calculator and have it tell you what's right, is saying, well, I don't like that radical in the bottom. Square root of 2, to get rid of it, the trick is multiply times the square root of 2 in the bottom. Because square root of 2 times square root of 2 is square root of 4, which is 2. But if I do it in the bottom, just anytime I convert a fraction, I got to multiply it by the same thing in the top, because I'm really just multiplying by 1 there. Otherwise, my fraction has changed. So I end up with 12 root 2 over 2. This is right, except that's also not reduced. 12 over 2 is 6 root 2. It's not super important that you know how to do this, but I'd like for you to know how to do this. The main thing is when you convert that to a decimal number, you realize, is it less than 12? Otherwise, I did something wrong. And 6 times 1.4, if I can do it in my head real quick, I think it's 8.4. So it's about 8.4, which seems about right as far as size goes. If I get something that's bigger than 12 or super small, I know I did something wrong. Okay, I'm well on track to finish here. Okay, equilateral triangles. So if we chop them in half, we create what's called a 30, 60, 90 triangle. And the pattern here, we don't know yet, but the easy thing I can do, if I just give you this number, it's like, oh wait, there's symmetry here. This is half, because this is the whole thing, so we know the whole thing from here to there is 10. So this other thing here has to be 5. And then if I do my Pythagorean theorem, I know that 5 squared plus something squared, I'm going to call it x. I like using x because b looks like a 6. 10 squared. So I get x squared. I'm going to do a little bit in my head. This is 100. I'm going to need to minus this from this side to get this alone. So minus 25. X squared equals 75, which means ultimately my x is the square root of 75, which once again, it's a fine answer. It's about, I'm doing this in my head. It's less than the square root of 81, so it's more than the square root of 64. So I'm just going to guess this is about 8.5. It may not be. It may be 8.4. It may be 8.6. But that seems about right when I look at my triangle. The other thing is, if you put this in your calculator, this is really 25 times 3, and I can take the square root of 25. So the other answer you might see here is not 25, 5 root 3. So this is 5 root 3. That is one of the possible ways to write that answer, okay? So let's try another one. So we got one here. In this case, this short leg here is 6. I know I've got to double it to get this. So this is 12, because once we've got that symmetry going on, it's half of an equilateral triangle. And then I'm going to do all the same thing again. I'm going to do it a little quicker. So I know 6 squared plus x squared equals 12 squared. Okay, this is going to be x squared equals 144 minus the 36 over here. And I get x squared equals, and I got to do this in my head now, 108 is what I hope it is. Let me make sure. Yeah, it's 108. And then when I take the square root of that, the square root of 108 happens to be, it's a little bit more than 10 point something, but it's also 6 root 3. So this thing right here is 6 root 3, which you can't see anymore, okay? 6 root 3. Do you notice a pattern? 5, 10, 5 root 3, 6, 12, 6 root 3. There's definitely a pattern here. So I'm not going to do all that again. You're just going to have to trust me that if I did this again and again, I'm going to always get this pattern. This number obviously doubled here, or chopped in half if I'm going the other way, and multiplying by root 3 when I'm going in the other direction. And once root 3 is approximately 1.7. So it's not twice as big, it's a little bit less than twice as big, which makes sense. This is twice as big, this is a little bit less than twice as big. It's in between. I got baby bear, mama bear, papa bear. Okay, so if this is 4, how long is the hypotenuse? That's right, it's 8. Running out of time. This is 4. This will be 4 root 3. Okay. Start with 4 here. So I've got 4 here, going down to here. Got to be half. It's 2. And going from here to here, 2 root 3. Finally, going backwards. Going backwards. Well, if I'm multiplying by root 3 going in this direction, what am I going to have to do going in the other direction? That's right. This is going to be 7 divided by root 3. I'm going to leave it like that for now. There's an equivalent form. But if I double that, 2 times that is going to be 14 over root 3. Okay? Now, this right here actually ends up being 7 root 3 over 3, which means this right here, another way to write this is 14 root 3 over 3. These are all equivalent forms, and they have decimal forms too. This is going to be 7. This is going to be probably about 4, and this is going to be around 8. I'm doing that in my head, but a little bit more than half, and then double. Okay, I am going to stop it there because I'm at 11 minutes. Ciao.